Okay, we're doing lecture first together, and then we are going to do rotations today. So I'll explain rotations in just a minute after we do lecture. So we are starting with electrochem, and we're going into batteries today. So last time we talked about electrons moving back and forth and forward and backwards. I want to do a little bit, well, let's go. I keep wanting to get ahead of myself. So today you're going to turn in 11.2 at the end, hopefully, and do 11.2 as part of the rotation. So we're going right in today. So why study electrochem? This is your first little part. I think it's the second part down. I mixed stuff up a little bit, so you're going to have to follow me along. Why study about electrochem? Because it's all about batteries. It's about corrosion on our cars. It's about the production of chlorine and sodium hydroxide for soaps. It's for fluorine, for strong teeth, for our aluminum cans. It's also a lot of our biological systems are using redox reactions. And we're going to do one of them together here. We're going to show it. And you don't have to be part if you don't want to, but if you'd like to, I'd like all the class to come up around the red area so we make a circle real quick. So just leave your stuff, come up real quick, and stand around the red circle. I need some so that we can make it this way. We're going to show that our biological systems are conducting electricity. So at all times. So I need a full circle because we're going to hold hands. You're going to have to hold hands. I'm sorry. Just get up here. Get up here. Everybody, come on. Get up here. Do not come sit down. Get your butt up here. Okay. It is. So this one right here, if I have electricity going in my body, and so if I complete a circuit with this, I can show that I have electricity flowing through my body enough to light these LEDs and to make the sound go. Now we're going to make a bigger circuit by holding everybody's hands. We're not going to complete the circuit until everybody's holding hands though. So everybody hold hands. You got to hold hands all the way around, and let's see if we can make a circuit all the way around. Okay, hold hands, guys. Hold hands, hold hands. Are you ready? We're going to complete the circuit. So the electricity runs through all of us. We are bodies that have to work because of electricity. If we didn't have electricity, our neurons wouldn't work. We wouldn't be able to function. I know, you can make the circuit go up and down. All right, good. Let's go back to our seats. All right. Okay. We have redox reactions going in us all the time. We have redox reactions around us. If I took a piece of copper metal and put it into a solution copper metal into a solution of silver nitrate, it would do a redox reaction. The silver would come out of solution, the copper would go into solution. But in order to capture the electrons moving, I have to separate those two reactions into those half reactions that we talked about last time. The oxidation reaction and the reduction reaction. I've got to separate them. Okay, so when I separate them, I get what's called an indirect. Like what we did just a minute ago with that circuit. If the circuit is not connected, if the positive and the negative part of a battery are not connected, the electrons are not going to flow. The reaction's not going to happen. But the minute I connected that circuit, or John did, or whoever was there connecting the circuit, then the electrons flowed. And when they flowed, we had an oxidation and a reduction reaction going. I am not holding you for this reducing agent and oxidizing agent. Just know that there's an oxidation and reduction going. Okay, so what is electrochemical cell? It's the transferring of the electrons. Okay, so we're going to transfer them. We're going to do it two ways. One is a voltaic cell, or galvanic battery, or galvanic cell, which is a battery. Okay, as we know it. It gives off electricity. It's what makes our telephones work, our phones work, our calculators work. But we also know that if the calculator gets low on battery, what do? We plug it in. When we plug it in, it becomes an electrochemical cell and pulls in electricity to recharge our battery, so that then we can unplug it and use it as a voltaic cell. Okay? So two words that you need to be, voltaic and galvanic are the same, but I like to use voltaic because it helps me remember, it gives me voltage. Electrolytic, I have to plug it into the electricity to recharge my battery. So that helps me remember which one's which. I hope that helps you. Wait for a second here. Make sure you've got those definitions down, because we'll be working with them today. And next time when you come, we're actually going to be making wet cells. Today we're going to be doing dry cell, meaning we're going to be doing stuff on paper to show batteries. But next time we're going to be playing with fruits and vegetables and different kinds of metal and seeing what kind of voltage we can get going. Okay? Are we okay to move forward? So I always put a little hint here again. Voltaic is just using the battery like you would normally. Electrolytically, I'm recharging, putting it into the electricity. Okay, so little hints to help you remember for the test are always good, right? We okay to move forward? All right. So chemical change is electrical current. So if I just took copper ions and I put zinc metal in, I would have a reaction going forward. Okay, with time, the copper would plate out and I'd get zinc metal. The zinc metal strip would disappear. That wouldn't really help me. I would know that zinc is oxidized because zinc is going into solution. And I would know that copper is reduced because it is coming out of solution, making a solid. Okay? These things I'd know, but as far as the reaction, it wouldn't help me any. It wouldn't give me any electricity. So we separate them. And when we separate them, in a wet cell, we do this. We separate the zinc ions and the copper ions. We put a zinc metal strip down in the zinc ions, a copper metal strip down in the copper ions. We connect it with a wire, sometimes a voltage meter to see how much voltage we're getting. But we also have to connect it with a salt bridge so that when the ions start building up on one side, the salt bridge will help balance the charge so the charge stays neutral. But here's the key. The electrons are transferred via the wire, so we can use them. Okay, they become useful to us. Okay, we separate them so the electrons transfer can occur through an external wire. This is a voltaic cell. This is a battery. Yes?
Can I ask a question?
Yes, ma'am.
Acetic acid, 5%, like the stuff we buy. Is it 5% by volume or 5% by weight?
I think it's by volume.
Okay, right.
Not for sure, but I think it's by volume. Okay, going forward. You are, during your rotations, going to watch 3 videos when you go to the blue. This is one of them. This is another one. The guy that talked, he's going to talk to you about electrochemical cells. And then the third one is an electrochemical cell battery where you actually get to see inside how what's going on, what's working with it. Okay? So those are the 3 that you're going to watch in the blue area. I'm just going to go forward. We're going to skip a little bit and go on to this next part. So find this first one that looks like this and leave that page, don't fold it underneath. Leave that page open that's next to it. So we're going to be working on this for the next several slides. Okay? This is going to be a zinc copper. So when we look at a zinc copper, you're going to set it up just like I did. Don't worry about putting the world ions there. Just put the Cu+2 and that. Put as much as I've got up there onto yours. Now, the salt bridge is not where the electrons go, right? The salt bridge is different. So we're just going to put the basics on right now. We're just going to write what we've got for that cell. So zinc and copper, and the zinc +2 ions and the copper 2+ ions. What's my anode? What's my cathode? Label the salt bridge. Connect the wire. Show my electrons going a certain direction. So do that much. And we're going to talk about each of them. Yes? Okay. Now, if you miss some of this, it'll be on the next several slides, so don't worry about it. But we're going to be working with zinc and copper. And that's important that we know that. And I can always set up something like this to start with. But one thing I need to do is go here. So do you see a sheet like this on yours? We're going to find zinc and copper. So if we look, zinc is about right here. Okay. And copper is somewhere around here. Okay, find them? So I'm looking at this number right here, and I'm looking at that number right there. Do you see them? This is easy. So you're going to find them on the sheet. Whichever one is lower is Leo. Lower is Leo. Okay, lower is Leo and will be on the left of your cell. Lower Leo left. Okay, the one that's on the top is going to be Ger, which is on the right of your cell. Okay, so this one, the lower one, which is Leo, is going to flip. What do I mean by flip? It's going to, instead of be as written, it's going to go zinc becomes zinc plus 2 ions plus 2 electrons. So it's going to be backwards. So underneath, and we'll see this in just a minute, so don't worry about it right now. This is going to flip charges, so it's going to become a positive 7.63. And we'll go over this in just a second again. And this is 3.37. All I have to do to get the cell how much voltage it can do is add those two now. That's it. Okay, so let's go over it again over here. So I have found the two that I need, which is this one and this one, right? The bottom one is zinc. Zinc one, I would change signs. Okay? Come on, next one. So I would set them up like this. I want to set them up so that each of the, whoops, it didn't exit out. So each of the electrons are on opposite sides of the arrow, so they'll cross out. So I can make myself a thing here. And this one was, zinc was what? As a positive. Don't remember. So 763 volts. And we made that positive, right? I'm going to fix that. Okay, what was copper? 0.337. Okay, volts. We would add that up and it'd be 1.100 volts. Okay, that's how much I could get off of that. So, as we're doing our cell, zinc is going to be giving off electrons. The electrons are going to be traveling along the wire this way. Because zinc is giving off electrons, and zinc, let's see if I've got the rest of them, is the anode. It's a negative source of electrons. Cathode is a positive, or the sink for the electrons. So we're going to add anode on this side. We're going to add cathode on this side. We're going to add under, oh, there's where my numbers are, where I added them up. I thought I had them, and I crossed out the thing. Okay, we added up and we got 1.10 volts for the whole thing. So this is a total cell voltage down at the bottom. That's all we have to put at the bottom. Okay, you see where the cell voltage is, total cell voltage? Okay, so let's finish. This is just explaining it. This is total cell voltage. It's standard. Now let's go finish labeling. This is how I remember it. So we labeled this side as anode, right? This is a phrase that I remember for this side. An ox is negative. In other words, getting ran over by an ox is a negative experience. Well, it's my anode. It's where oxidation occurs, and it's negative. Okay? This is where we're putting the zinc equation, right underneath here on that big area. If you filled it in with cathode, or, anode, then you need to put that above it somewhere. That equation needs to be there. Okay? It's the anode, oxidation negative. Put that off to the side. On the other side, we labeled it as reduction. When I think of reduction, I think of, red cat pause. Okay? Red cat pause. And that means reduction, cathode, and positive side. So this is my negative side, and this is my positive side of my battery. Okay, we're also going to include the equation down at the bottom. Now, this equation down at the bottom tells me what's happening. Zinc is becoming zinc plus 2 ions plus electrons. So that means this is going into solution to become zinc plus 2, and this is becoming smaller. So would you draw that on your electrodes? What do you think is going to happen on the other side? Well, copper is going to gain 2 electrons and become copper metal. So copper plus 2 is going to come out of solution add on to this and make it bigger. Okay? We also have going through the salt bridge anions to the anode and cations to the cathode. They have to do that in order to balance the charges, because if you look over here, zinc's coming into solution, making more positive, so we need to pull negative from the salt bridge to neutralize it. And over here, cations or positive ions are coming out of solution, so I'm going to have negative ions left over. So the salt bridge provides cations to balance that out. Okay, whoops, let me go back. So usually up here at the top, we're going to put in a voltage meter, and it just is a little, I didn't draw that very well. Let's try that again. I'm going to draw it right in here. It's a voltage meter. Will show me the voltage. I'll also show me my electrons are moving this way on both sides of the wire. I do need to connect the wire, the metal with wire. Okay, and we said that the total voltage of the E cell was 1.10 volts, right? And you could use a capital V there if you wanted to. This is a complete battery. We've labeled everything, okay? Usually we'd also add in the E for this is the 0.76, and the E for this was 0.3, whatever it was, okay? That will be required on the other ones, but other than that, I think that is all. So you're going to be doing 4 more of these batteries, just like I did, but with different elements. So let's go, and there's some up on the top there. We're going to practice with the sum on the top. Let's try, and they're not necessarily in order because I messed them up. So we're going to work with this one first. So that one's the one right above. It's the practice that we just did. You see it? I want you to find them on your table. See which one's flipped around, change the sign on that, and figure out what the voltage is for that cell. Is it going to be negative or is it going to be positive? What is it? So we're going to work back up the table here. So once you find it, go ahead and put the voltage off to the side, like over here. And if it's backwards, just change the sign on the voltage. Then you just add it together. Let's see if who can find out what the voltage is first. You're just finding these 2 equations on the chart and seeing if they're as written or if they're backwards. If it's backwards, change the charge on the voltage. And then add them together. Did you find them? Found iodine there, and the water's right below it. Anybody got it figured out? It's about the middle of the chart. Both of the things are right there. Did you find them? So the overall equation would be this. Did you get that for the voltage as written? This was a negative voltage, right? Oops, we got a different number in there for those. Okay, so on your chart it's 0.53 was right, but the other one was 0.4, so you had a 0.4 here, right? Is that what you said? Okay, so you're going to be off a little bit for the numbers here, but you should still end up with a negative. Nope, you'll end up with a positive. Is that number? But I just did something weird here. Okay. All right.
Well, no, like it's the 0.82.
Oh, it is that number? Am I looking at the wrong place?
It's like right under the, yeah.
Oh, it's under the zinc. Okay, I was looking at the wrong one. Yep, okay. All right, so we had a negative. What type of cell is this? Is it voltaic or is it electrolytic? If it's negative, I have to put energy into it, so it's an electrolytic cell. So this is electrolytic. This would mean I'm charging. I've got to charge it. Or I've written the equations backwards if I want a battery. Okay? All right, going forward. That's what I just basically said. All right. Now, I want you to find these two equations, and this would be at the very top. I gave you this little pretty picture at the very top, so I like I'm working up the page, okay? Find these, figure out which one of these I'm going to use. Remember the lower is going to be on the left, which is going to be the one I flip. Hint. Okay? See what you got. So we're doing cadmium and iron, sorry. So find cadmium and iron. If I remember right, cadmium's about right here, and iron's like right close to it, somewhere like that. I can't really read those, but... Okay, which one am I going to use? Which cadmium am I going to use? Is it being reduced, or is it being oxidized? Reduced would be the bottom, oxidized the top. It's being reduced, okay. So we're going to choose this one. It would be the one that's the farthest down on the chart. Would be the one that would be reduced. No, the one farthest down on the chart would be the one that's oxidized. The one highest would be reduced. Okay, so iron would be oxidized right here. Let's see if we got them right. Cadmium we did, and so we got iron right. So what would be the voltage of this cell? Would it be a good cell? How much voltage did it give off? Forgot to put the last one in as one thing you go down. You only got negative, well, that's not even the fend of it. There we go. Whoops, there we go. 0.04 volts. Not a very good battery. Okay? So you can see how you can play with these and get different voltages with different metals. Now, let me explain what we're going to do next. We remember that when you have a negative voltage, you're going to have an electrolytic cell. So if it asks for an electrolytic cell, you're wanting a negative voltage. So you're going to flip the top one, not the bottom one. If it asks for a voltaic cell, you're going to flip the bottom one. Okay? We are going to break up into 3 groups. You can move to wherever you would like to start. Okay? In the green, you're going to build the paper batteries and make sure to include all the parts and do your quiz. Okay? In the red is going to be my help area where I can check to see if you're doing it right. Everybody's going to come through here. It's not going to be an option because I want to make sure everybody's doing the battery right. On the blue area, you're going to watch the 3 videos. On the back of your green sheet, at the very front of your note packet, you're going to write 3 science facts for each of the 3 videos. 3 things you got out of each video. Okay? Yes, I know the one is very annoying, and you'll understand which one I'm talking about once you hear it about 3 or 4 times. It's okay if you skip over that after you've listened to it a few times and got your 3 facts. Okay? But the other 2 I would like you to listen to all the way to the end so you get all the information that you need. Okay? Questions? Okay, there's earphones over here. There's mouse over here that you can use with your computers so you can watch the things. Again, red, help area. Green, on your own, but do your quiz and then start on your batteries. And then blue, back to watching the videos first. So would you move to where the area we'd like to start in, and we'll start with a 20-minute timer in each area.